Today we're going to be talking about parallel lines and transversals. Parallel lines are lines in the same plane that do not intersect one another. So in this picture, line P and line Q are parallel lines because they're running next to each other. Even if we continue those lines on, they will never intersect. Whereas perpendicular lines are lines that intersect and form four right angles. A transversal is a line that crosses over, intersecting two or more lines. So in this diagram, line T is our transversal. It's cutting across these two parallel lines. Whenever we have two parallel lines cut by a transversal, four angles are formed between the parallel lines, and that's angles 3, 4, 5, and 6 here. These are our interior angles. And four angles are formed outside of the parallel lines, above and below them in this picture. So angles 1, 2, 7, and 8 are exterior angles. When a transversal intersects parallel lines, corresponding angles are formed, and corresponding angles are congruent. So what do I mean by corresponding angles? So I basically have a set of four angles up here and a set of four angles down here. So if I look at these four angles independently and I look at these four angles, I can match up the ones that are in the same position. So the angle with one arc line here is in the bottom right-hand side of this set. This angle with a single arc mark is also in the bottom right in its set of four. These two angles with the single arc are corresponding angles, and they're going to have the same measure. If this one right here measures 120 degrees, I know this one is also 120 degrees. Same thing for the angles with the two arc marks. So this one is in the top left. Here we have another one in the top left. Those two are corresponding angles. They'll have the same measure. So let's take a look at this diagram. They want us to find the measure of angle 1 and angle 2. So I have a set of four angles over here, and I have a set of four angles over here. And I notice that angle 1 is in the same position as the 110 degree angle. They're both in the bottom left. So angle 1 is also going to measure 110 degrees. Then I notice that angle 1 and angle 2 are supplementary. They're next to each other, and together they will be 180 degrees. So 180 minus 110 leaves me with 70. So the measure of angle 2 is 70 degrees. Sometimes you're going to be asked to find more than just two angle measures. So in this picture, I'm being asked to find the measure of 7 angles, and I'm only given one angle's measure. I only know this angle right here is 75 degrees. So let's start trying to find the other angle measures. So let's start with angle 1. Angle 1 is also going to be 75 degrees. I notice that he's a vertical angle to my original angle. So he's vertical to the given angle. And the given angle was 75 degrees, so that helps me figure out that he's also going to be 75 degrees. Angle 2 is actually a supplementary angle to that 75 degrees. So 180 minus 75 leaves me with 105 degrees. I know that because angle 2 was supplementary to the given angle. The two of them added up to 180. Angle 3 I can find for the exact same reason. Angle 3 is also supplementary to the 75 degree angle, so it's going to be 105 degrees. Now I'm trying to find angle 4. Well, I noticed that angle 1 is in the bottom left, and so is angle 4 in its set, so they're going to have the same measure. So if I go back to angle 1, it was 75 degrees. So is angle 4. I know that because it's a corresponding angle with angle 1. So they're going to have the same measure. Angle 5 is also a corresponding angle. He's in the top left to angle 2. So 2 and 5 are going to have the same measure, so 105 degrees here, because he's corresponding to angle 2. Angle 6 matches up with the given angle, the 75-degree angle. They're in the same spot. So 75 degrees, because he corresponds to the given angle. And last but not least, angle 7 is in the bottom right, same position as angle 3. So 105 degrees, because it corresponds to angle 3. Let's look at our next example. It says a store owner has used pieces of tape to paint a window advertisement. The letters are slanted at an 80-degree angle. What is the measure of angle 1? So they put some tape lines on here to make some straight lines, and then the letters themselves are at an 80-degree angle. And they want us to find the measure of angle 1 right here. So I can use this tape line and this angle line here to view this as a set of 4 angles. And 80 degrees would be in the top right. So when I do the same thing over here, that means this top right angle is 80 degrees. And I notice that angle 1 and the 80-degree angle are supplementary. So if I do 180 minus 80, I'm left with 100 degrees. So the measure of angle 1 is 100 degrees. When you have a transversal intersecting parallel lines, another thing that we have are alternate interior angles and alternate exterior angles. And a cool thing about alternate interior and alternate exterior angles is that they're also congruent. So remember, when we had parallel lines, the interior angles were the ones in between the parallels, inside. So alternate interior means the opposite ones. So the ones with a single arc here are opposite on the inside. They're going to have the same measure. If this guy's 115 degrees, this one's 115 degrees. And same with the double arc angles. Now the exterior angles were outside of the parallels. So in this case, above and below the parallels. And the opposite ones, like these two with 2 arc marks, they're going to have the same measure. If this guy's 60 degrees, this one is 60 degrees. And the same with the single arc ones. So it's another shortcut way we can find angle measures. So in this case, we've got some airport runways here, and they want us to find the relationship between these angles that they've marked. So we have one runway here, this is our transversal, and 2 parallel runways here. And we've marked the different angle numbers. So they wanted us to find the relationship between angle 3 and angle 6. Well, since this would be between the parallel ones, inside here would be our interior. And if you notice, angle 3 and angle 6 are not in the interior, which makes them exterior angles. So 3 and 6 are opposite each other, but on the outside of the parallels. So angle 3 and 6 are called alternate exterior angles. Alternate exterior angles are congruent, so angle 3 and angle 6 have the same measure. If we look at angle 2 and 7, they are on the interior. They are between the parallels. So angle 2 and angle 7 would be called alternate interior angles because they're opposite each other on the interior. And alternate interior angles are also congruent. So angle 2 and angle 7 will have the same measure.